And we're live. Hello.
Hi, Ramon. How's it going?
I'm good, thank you. How are you, Laura?
Good, doing well, thanks.
Glad to hear it. Yeah, and I'm excited. I love doing these live streams, and I think yesterday you and Oscar brought up performance quite a bit. In case you missed it, you would by any
Mm,
chance to have a link to the discussion that you and Oscar had yesterday?
I can momentarily.
Cool. In the meantime, in case you missed it, folks, we had Laura kick off her new series called Eli 5. Is that, or is it Eli 5?
I usually spell it out, I guess, but
Okay.
I don't know if I've ever heard anyone say it out loud. So,
Maybe I'm saying it completely wrong. But yeah, it's about explaining like the core concept of is like explain like I'm 5. That is that fair to say?
oh, absolutely.
Awesome. I think I've got a workspace ready here, and we can have at it. And we'll need some stuff here. So let's. Yes, I'm good to share my screen. And you know what? Before we get started, since folks are still coming in, I'm just going to make a quick tweet letting folks know that we're live. You don't mind, do you?
Sounds good. Not at all. And maybe we can drop a link to the tutorial.
That
well.
is a solid idea. Let's do that.
Asking for a me, I guess.
Which I've got right here. You can't see it because I'm not sharing my screen yet. Where is my StreamYard? There we go. And I'll put that into the chat. Oh, cool. You put in the Eli 5 link. And I'll send that to you as well, so you don't have to in the private chat. Cool. I'll just quickly send out a link that we're live. Send out a tweet that we're live. Laura and I are live and in profile. Not really. We're profiling Wasm code. Now we get to see live how I come up with bad tweets as well. Excellent.
Bad tweets are fun tweets.
Bad tweets are mostly. there is a bearing of responsibility as well, at least on my side. Okay, let's see how this looks. The browser can access your screen. Try capturing a different screen to see if this continues. That's odd. I'm sorry. I might have to restart Chrome.
Okay.
I'll be right back. Do you mind, Laura, just holding down the fort while I restart?
Sure
I'll be right back.
Mm-hmm. So for those of you who are just joining us, if you haven't seen one of these workthroughs before, Ramon and I have been working through the tutorial that's linked in the comments. And we've been building our first WebAssembly app, and WebAssembly is also known as Wasm. So we've been through all kinds of steps where we've built the app, and we have debugged, and we have added interactivity and testing and so on. And today we're going to be optimizing for performance. And neither Ramon nor I are native Rust speakers, so to speak. But Ramon is a lot further on his Rust learning journey than I am, which is to say, I am not actually on a Rust learning journey, and Ramon is. But not all the code that we're writing is in Rust. Some is also in JavaScript, because that is the beauty of WebAssembly. Hey, Ramon.
Yeah. Hi again. I think. Oh yeah, I can see my screen is shareable again. Give me 1 sec to clean up. I'm sorry, folks. I usually am better about getting set up responsibly. So how do I do this? I usually struggle with Mac OS, the full screen stuff, but I think I've got it now. So let me share my screen. There we go. Put us at the bottom there. Nice. Can I make my dock go away? Does the dock? There we go. Nice. All right. So let's see. A couple things need to be bigger here. We need this to be bigger. Maybe a touch bigger. What do you think, Laura? And folks in the chat.
Yeah, I think it's good for me.
Yeah. Cool. If you're watching and you'd like this size to be a little bit bigger, please, 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 just let us know. So we are going to be doing profiling, so time profiling. And I'd love to start, if I may, Laura, getting a gut check from you. What's your understanding of time profiling in this, in the context of not just WebAssembly, but apps in general?
So I think this is the first time that I've heard performance optimization referred to as time profiling.
Okay.
And so I'm assuming that what that means is optimizing the amount of time that it takes to run the code. Is that right?
I think so. It's checking to see how long individual parts of our code take to run. So I think you put it, in fact, much better than I could have. I'll do a git pull here. I forgot to do that. Well, yeah. So today, since we tend to iterate on this, I will be driving and Laura will very kindly be navigating.
Right. Yep. So we will be starting by creating a frames per second timer with the window.performance.now function. This FPS timer will be useful as we investigate speeding up our game of life's rendering. So I'm curious what window.performance, that sort of makes sense, but the .now is interesting to me.
Yeah.
What
and I think
is that?
And what we can do is go in here to have a look at what those are. So not only do we have a tutorial on how to do the actual performance, but also, I'm sorry, I shouldn't be. I'm just driving here, not navigating. Sorry.
That's okay. Right, so we have available tools. The window.performance.now timer, that function, the performance.now function returns a monotonic timestamp measured in milliseconds since the web page was loaded. I think it's adorable that they threw in monotonic in there. Like, we just need to make clear that this function is not the TARDIS, right? It's not. It's not going backwards.
Is that what monotonic means?
Monotonic, so it means it's single tone. So it's if it's monotonic, then it's either strictly increasing or strictly decreasing. But it's not like going up and down. So
I see.
That's so cute.
It comes into what we were talking about when talking about documentation, right? It's all about that specificity, isn't it? And I like that a lot.
Yeah. Just in case anybody was worried about it. And so calling performance.now is a little overhead, so we can create these simple granular measurements from it without distorting the performance of the rest of the system and inflicting bias upon our measurements. So that's interesting. I'm still wondering about the .now. What does .now do?
I think what it's doing...
Is it like taking a little snapshot?
Well, actually, you know what? We are in a browser. Absolutely nothing is stopping us from trying it out. If I can find the developer tools, make sure that the size is okay. Size looks okay. What happens if I call clear? Nice. So it's window.performance. And check it out. I like it when the browser gives us like a little bit of a preview. There's some stuff in there. And it's got access to a function called now. And what this now function does is give us the amount of times in millisecond, the amount of time in milliseconds that has passed since this window was loaded.
Okay, so it is a snapshot idea. Right. Okay.
When I call this now, it's been exactly just over a minute since we loaded this window. So that's what the now function does.
That makes sense. Great. Okay, so we are going to use this to Time R. What are we using it on? We're using it on. Well, I guess we're going to find out where we're going to use it. First, we have to create it. Okay. So we're going to set up this function now, but first, I guess we're going to. So extern crate, is that like import?
Yes.
Okay, so we're going to import from crate the package manager a module. Is that what it would be called in Rust? Would that be WebSys? Is that a module?
That's a crate.
It's a crate. Okay. Right. Okay. And then what is the cargo is the package manager. Yes, because I love that. There's cargo and it contains crates. Yep. Okay, great. And so we've got that. Do we have that? Oh, I see it. Yep. So you've got it on the second on line 2.
Yes, we're using the console log functionality from WebSys. Mm-hmm. These are bindings between WebAssembly and the JavaScript, the browser.
Ah, okay, gotcha. All right, and so now we need to declare our. Oh, we're still in available tools. I was about to declare this now function like that was our job, but it's not. We're going to use it. Okay, so I guess we can go back to time profiling then.
Cool.
Yeah. Okay. Okay, so we're going to start by declaring an FPS object to our Wasm game of life /www/index.js. And that FPS is it's interesting to me the way the notion of what's a constant varies from language to language. Because it's completely counterintuitive to me as someone coming from Python, that we would have a constant that is also a class.
Why?
Or it gets a class, I guess.
Why?
That's interesting. Well, I guess maybe we don't actually use constants super often in Python, and you would sort of use a constant to indicate, to communicate that you don't expect this to change. Right? It's like it's like a value that should sort of stay the same, you know?
Could you argue that a class never changes?
Sure, yeah, but like a class isn't a value. At least in Python, it would be like a class that has, characteristics. So you'd be declaring this object and it has all these different characteristics as opposed to a value.
Yeah.
And used to seeing constants as basically a value, like an immutable value.
And in Ruby, it's the same, huh? You've got I use, and in Objective-C actually, and in C, I use them to sort of permanently store a value. For example, for enums or something, to expect that these will never change. However, right in JavaScript, const is used more to assign. Now, I believe the history there is that in the beginning there was var. Which was an infinitely reassignable variable. Let is reassignable but not redeclarable. You can have let a equal something, then and then say a equals something else later on, but you can't declare let a again.
Okay.
Const, on the other hand, is, like you said, immutable.
Right. Yeah.
And
so that's interesting.
I know where you're coming from, and that's why I apologize for being perhaps inadvertently facetious, but I like that discussion. I like that I like that argument because it's true. In Python, you do use constant, and in Ruby, for example, you do use constants differently, but it's not like we're using it that fundamentally differently here. That said, I've never seen it used like this. const FPS
Okay.
equals new class. Never seen that.
Okay, not just me.
Oh no. Never seen that.
Gotcha. Okay. And so then we've got
What do I need to do before we
where are
start?
we?
One thing I realized I need to do, I'm very sorry to take us off
Mhm.
track a little bit, is I just realized I'm going to need to hide our faces for a second. I
Okay.
realize I'm still working from my fork, as you can see here.
Mm.
So what I need to quickly do is copy this, git remote set URL origin, and then copy this. And instead of, what was your GitHub username? Is it Laura_E_Langdon?
That's my Twitter handle. It's just Laura Langdon.
Like that.
Mm-hmm.
There we go. Now we're all set.
Yay.
Sorry, I cut
Sure.
you off there. So we're doing this here.
Yeah. Right. So where do you want to put this?
We'll start by adding an FPS object to Wasm Game of Life. I would say, because this is a class declaration, it could be hoisted. That is, its declaration is persisted at the top and accessible anywhere.
Mm-hmm.
So I would be tempted to just copy this as is.
All right.
And maybe cover it briefly.
Sure.
Let's put it here. What do we have here? We've got a class with a constructor that we're looking for an element called FPS,
Mm-hmm.
an empty array of frames, and a last time performance now. Okay. So we've got a timestamp for when,
Yeah, so we got a timestamp, and that's I always think of things as like snapshots. This is what things look like at this precise moment. Yep.
Yeah.
And then we're going to have this render function, which will convert the delta time, so the time passed, right, since the last frame render, into a measure of frames per second. Okay, so this sounds
I see
like
an assumption being made there. I'd love to ask, what's a delta?
So I would guess that it's the difference. Oh, it totally is the difference, because there's a minus, right? We're subtracting. It's the difference between now and the last frame timestamp. Yeah.
Is that a mathematical concept?
It's totally a math thing. Absolutely. Yep.
Cool.
And so then, right, so we've got this last frame timestamp equals now. So we take a timestamp that is the time now, and from that we will subtract the timestamp of the last timestamp, and see that difference. So we can see how much time has passed in between those two measures, those two snapshots. And then we're going to save only the last 100 timings. What is a timing here? Okay, well, let's see if we can figure it out. So we've got this frames
the number of
push
frames per second.
FPS. Yep. So frames push. That's interesting. What are we pushing? We're pushing the FPS, the frames per second, to where?
To this. An empty
and
array.
That's push?
Yes. Are you familiar with stacks?
Yes.
Yeah. So stack on top. You've got push. And I think shift is remove from the bottom.
Ooh, that's really not stack-like at all.
Oh, it's not stack. Sorry. We started from stack because you've also got pop, which is pop off the top. But then I forgot there's shift, which is...
Okay, which is pretend this stack is a queue?
Yes. By the way, you know what it's called for adding something to the bottom?
No.
So if it's push and pop for pushing on top and popping off the top, if it's shift to remove from the bottom, can you guess what it's called to stick something in the bottom of JavaScript?
I'm literally looking at my keyboard for hints. I don't know.
It's called unshift.
Oh, I like that though. And like as a math instructor. Oh no, I love it.
Carry on.
Like as a math instructor,
yeah,
I would not use the words subtract and divide. I would use unadd and unmultiply. because it really pulls together the idea of inverse operations. Like you have an operation and you have an operation that undoes that operation, and it would help sometimes
I like that.
that framing, you know.
I
So
like that
I
a lot.
really like that actually.
I
Shift
know.
and unshift.
I think it is good naming, but the inconsistency bugs me.
Ooh, yeah,
And
that I get.
my consistency brain is the one that's frustrated by it. But sorry, I
Uh-huh.
took us off topic.
Sure. No, I think with that's like the whole thing. That's our thing.
Yeah.
That's the Ramón and Laura show is all the rabbit holes.
In which we complain about JavaScript.
Okay, so we're pushing that frames per second onto our stack, and then if those frames, if the length of the frames, because that was an array, was it?
Yes.
Can we scroll up a little bit?
Oh yeah, sorry.
Yeah, okay, so that was an array. So the length of the array tells us the number of frames. And if that is greater than 100, then we're going to we'll pull from the bottom the older ones.
Yeah.
Right? Okay.
Last in, first out?
This would be
first
in, last out, right? Like, yeah, pretend this is a queue.
Yes,
right?
This is essentially a queue.
Yeah. Okay. And so then we're going to find the max, min, and mean of our latest 100 timings. And I wonder why we're doing this. So this is fun. Right. So we've got the minimum is infinity. How? What?
So we're trying to calculate what the minimum of a bunch of numbers is.
Yeah.
So what we're going to do is loop through them. And then we're going to set the minimum to be, which you see here, the minimum to be the minimum, the smaller one of two values.
Yeah.
So in order to start at the very beginning, we set minimum to be infinity. That it's not technically infinity, it's the largest number possible in JavaScript.
Well, that's okay. So that's what I was stuck on, was I was like, now I know that's not a number. But you're acting like it's a number. What number are you pretending is infinity?
Let's find out.
I mean, not you, but like, whatever,
no,
whoever declared this is a thing.
How do I?
Oh, can you go back for a sec? I think it's more. One more. This infinity is not enumerable, and so fellow math people will wonder which infinity we're talking about here.
Oh yeah.
Because like we actually have different infinities, and some of them are countable and some of them are not. And so like now I'm like mapping, oh, okay, wait, which one is this? This is the real numbers. Okay. Anyway, sorry.
No, all good. So the initial value of infinity is number of positive infinity. The value infinity is greater than any other number.
Yes.
So what if we just
what is it?
console log infinity? So what we got? Okay, that's not very.
It's infinity. Let's call it infinity. Where did that 0 come from?
We divided. Oh, here it is.
Power of 10.
10 to the power of 1,000.
Okay. All right. So we're pretending that 10 to the power of 1,000 is okay. Cool. And we're going to call it infinity. I like that they threw that line in there. We're going to pretend this is infinity. Cool. Okay.
I'm sorry. This is going to bug me if I don't find out at what point. At what point does it turn into infinity? See, because 10 to the 500 is infinity. So what does that mean? Is 100 Oh, I'm sorry. I know this is completely.
No, I love this. This is our stream, man.
Yeah,
true. And we can rabbit hole.
Oops.
What's that? No, it's my party, and I'll cry if I want to.
I like that.
It's our stream.
So we'll rabbit hole if we want to.
We'll rabbit hole if we want to.
So is it 300? It's still E plus 300. How do you call that? E300?
Yeah. E plus 300. But okay.
Do a little binary search here.
Yeah.
Okay. Oops. It really is. Could it be
Ooh.
301? No. How is this? This sounds either arbitrary,
Yeah.
infuriatingly arbitrary.
Does this depend on, like, is this system dependent? Would you get the same result running this on a different
go as far
system?
as to say this might be browser dependent.
Oh.
Okay, 307 is still 308. Why? That's tremendously frustrating. What's is the fact that it's divisible by 3 or 9 or something?
This isn't divisible by 9.
Fair point.
Okay. All right. Well, that was fun. I mean, frustrating, but fun.
So yeah.
All right.
So we got infinity and negative infinity.
Yep. And we're starting our sum at 0. We're going to run through this loop, and we're going to add up all of our frames values.
Yep.
Frames.length. Yeah. Wait, what?
We're
what values are in the what are the elements of frames?
It's these ones, FPS, which is
the
1
frames
divided
per
by
second.
Yes.
Okay. Cool. So we'll find the biggest one of those and the smallest one of those, and we're going to find the arithmetic mean, which is the sum divided by the length of the array. That's all pretty straightforward. And we've got this. Oh, sorry. Go ahead.
No. Go ahead.
Frames per second dot text context. Frames per second. So we've got a latest. So we're going to math.round FPS. So what does round do here? Is it rounding to the nearest integer or?
It is rounding to the nearest integer. What I never remember is what the strictness is.
So it's 2 decimal places.
Is it? No, I think it's the integer. See, math round 5.95 gives us 6.
Oh, I mean, yeah, it's only considering out to 2 decimal places. Sorry, like if you had 5.954.
Let me try that. Let me just comment these out. I do love this about MDN. That you can just have a little JavaScript console here.
Mm-hmm.
So math.round 5 point, what did you say?
954. Just looking at their previous example. And then we could compare that to 5.955.
This is 6 pretty consistently.
Mm-hmm.
Because it's rounding up to the nearest integer. However, I believe it takes a no. What? Sorry, I thought it took a second parameter that would let you have significant figures. But I guess I'm wrong.
Now, in our case, we're talking about frames per second, and so we would only have discrete. We would only have integer values anyway.
Yeah. Which is why we're rounding.
Except for the mean. The mean might not be an integer value.
Well, actually, if we're dividing 1 divided by delta times 1,000, that might actually give us a decimal number.
But the mean is not the FPS. It's
the mean is the sum of all FPSs.
Yeah.
Divided by the length, but the FPS itself might be a floating point number as well. Because the delta is a difference in timestamps. So dividing 1, dividing 1 by delta is already.
Integer minus integer is integer. So 1 over some integer. Yeah, so that's going to be a rational number. But actually, it's going to be, we're going to have moved, since we're multiplying it by 1,000, we'll have lost anything beyond, I mean, even multiplying it by 100 would do that.
Well, it depends, doesn't it? Actually,
Why
not
is it 1,000?
Milliseconds. Remember, performance.now gives us milliseconds.
Yeah. So that is the reason. So that'll be an integer.
Well, let's find out.
If we're multiplying something by 1,000, something that might have gone out to.
Okay, let's try something silly. Okay.
Mm-hmm.
Let's do, instead of having a const now, I mean, yes, let's have const now, and then we'll do another performance now. Okay?
Mm-hmm.
Ignore that. So we're just going to calculate the delta between 2 calls of performance now and set that to be the FPS.
Mm-hmm.
Why would that be infinity? Because 1 divided by delta is so infinitesimally small. So close to 1. No, wait. So delta is so small. Actually, we can do that.
Mm-hmm.
It's as good as 0. My browser is running this so fast.
Okay. Yeah. So that's, but it's not even defined really, and it's, okay. It bugs me that it's saying infinity instead of undefined. But okay.
Yeah, no, I know what you mean, but yeah, and different languages and engines will treat.
Mm-hmm.
I remember I actually learned to code using graphing calculators.
Oh, uh-huh.
And there, I remember it would throw an error like cannot divide by 0.
Yeah.
But
and maybe, you know what, I think maybe it's good that we're talking about this, because it's good to be able to predict, what kinds of edge cases your code might run into.
Totally.
Right?
Absolutely. Yeah. So what we're doing here is, oh, sorry, I'm not driving.
What did we do with that trim at the end of the previous one? So we've got an average, we've got a most recent, the latest, the average, the min, the max. What are we trimming?
I believe it removes spaces from the sides of a string.
Oh. Where did the spaces come from?
Oh, here. Right?
But in our code.
Oh.
Where are they coming from?
I think they're added. You see? It's kind of like a multi-line string.
Oh, I see. Okay. Gotcha. All right. Makes sense. Okay, cool. So then we're going to call FPS render on each iteration of render loop. So we got to find our render loop declaration. And then within that, we need to add fps.render.
Mm-hmm.
And then we're good, right? With that part, I think we don't do anything else here. Yep. We're going to add the FPS element to our Wasm game of life /www/index.html just above the canvas. And so then but why in me is like, why does it need to be just above the canvas?
I don't know. It can be below it.
But they told us it needs to be just above, or they said that's where we will put it. Why did they say that?
I think I suspect it might be a stylistic choice.
Okay.
Is my guess.
Cool. Mm-hmm. So we added the div ID FPS, and we're going to add some CSS to make its formatting nice. So we're going to add FPS white space is I don't remember. I've used this in CSS, but I don't remember what that does.
Well, let's find out. Have I mentioned I love MDN?
I am becoming a big MDN fan as well.
It's marvelous. And here you can even test out the differences.
Uh-huh.
So what the pre does is it leaves the formatting, the indentation of the string as is.
Okay. Okay. Cool. And then our font family is monospace. Nice. And we'll just need to go back to the tutorial maybe. Yeah. Great. And so now we can refresh our localhost, and now we'll have an FPS counter.
Now, by refresh, this does mean first.
Start
this again. Yes, I first need to Wasm pack.
Mm-hmm.
Then I need to clean up. I think we forgot to commit this change to have this duplicate declaration of cells. So we got to remove that. Oh, Akil's here. Hey, Akil. He says MDN also launched something MDN Plus.
Ooh.
Where did I did see that here. Support MDN and make it your own. Yeah, that's interesting. Did not know about that. Thanks for mentioning that. Interesting. A new premium service on MDN that allows users to customize their experience on the website. Interesting.
Huh.
Thank you for sharing.
Check that out. Yes,
yeah.
Thank you.
So let's try Wasm pack building again.
Mm-hmm.
So that's built. Then we'll go into www. We'll do an npm install. It's been a while since I've run this. And then we'll do an npm start. Was it?
I think so.
That was good. Localhost 80. Ha! That
okay.
Doesn't look right. This is giving me reminders of what happened last time. Runtime error unreachable. Function new. Oh dear. Is the panic still there? The panic is still there.
Oh.
In case you're joining, last week we committed a panic and I forgot to remove it. That's built again. We can npm start again, and we should be okay again. Let's see.
All right. Yep, and we've got our FPS timer. And does our pause button still work? I mean, I can't imagine why it wouldn't, but yay!
Is that? I hope that's not headache inducing.
I'm not looking at it. I'm looking at the counter.
Yeah. So this is interesting. The average is about 145 frames per second.
Mm-hmm.
And usually most screens have a frame rate of 60 frames per second.
Mm-hmm.
But I'm using a monitor that allows me to have 144 frames per second. And so the browser conforms with that.
Nice. And Akil is celebrating with us. Thank you, Akil.
Oh, yeah. Thank you. Yeah. Cool. So we've got our frames per second. We've got our frame rate, which is cool.
Cool. And then we're going to use that for something, I assume.
Yes, we are. Here we go.
All right. So we're going to time each tick of our universe using console.time and sorry, there's something right under our suborbital logo. Time end. Okay. I'm all like moving my head down like that's going to help.
Someday it will.
Yeah. Okay, so to measure how long each invocation of universe, each tick of our universe takes, we're going to use that via the website. Great. So we need to add that as a dependency to our cargo.toml.
Yes, and I believe...
Which we may already have. Yeah, because we were already using it.
Mm-hmm.
Now that's interesting because we're not specifying a version or features. Oh, no, we are. We're just doing it in one line instead of splitting it.
Exactly.
Okay, cool. And so then because there should be a corresponding console.timeend invocation for every console.time call, oh, that's interesting. It's convenient to wrap them up in an RA2 type. I don't know what that is.
Me neither.
Resource acquisition is initialization. Oh, it's not a 2.
No,
It's actually 2 I's. It's not Roman numerals. Okay.
And I've never heard this. It is used is associated most prominently with R C++. Other names: constructor acquires, destructor releases. Ah, resource allocation. I have heard of this concept. So
Yes.
because this to me is like super reminiscent. I think we talked about this previously. Like, well, I started my career programming macOS apps using a programming language called Objective-C.
Mhm.
And I am infinitely grateful for my experience with this, because like C, whenever you initialize a variable, whenever you assign a value to it, you need to allocate memory for it.
Mhm.
Now, Objective-C was a little bit user-friendlier than C in that you didn't need to specify how much memory you were allocating, but you did need to say, like, hey, allocate some memory for a string.
Right. Right. And we've been doing that in Rust, right? Where we've been declaring I32 and so on, like integers of 32
True.
bits.
Yeah. True. But, and this is where I'm going to call it RAI comes in.
Okay.
When you're done with a variable, you need to manually say, hey, deallocate the memory. And if you forget to do that, or if you do that the wrong number of times, then you end up with stack overflows and that sort of thing.
Mm-hmm. So this is super timely for me because I'm writing up a blog post for Oscar's writing Wasm by hand.
Oh yeah.
And we have to write an allocate function and a deallocate function.
Cool.
So this is good timing for me. Serendipitous.
Yeah, fantastic. Yeah, I'll be very keen to read that, because this stuff, like, I'm infinitely grateful for this experience because it taught me a lot about, concurrent programming and that sort of thing.
Same.
But yeah, so we're going to be doing that, but with time profiling.
Yeah. And okay, so we already have our, wait, which file are we in? Are we still in the toml or did we go back? We went back to the librs?
I think in librs, yeah.
Yeah, okay. And then, so we've got our extern create websys already. That's an external dependency, right?
Yes.
Or external, would you call it a dependency here?
Or
we listed it as one in our toml, right?
Yeah.
Yeah, okay.
We're saying, hey, let's use that.
Cool. And we've got a public struct. And that's like what a class is in Rust, if I remember correctly. Sort of analogous, is that right?
Mostly.
Okay.
Mostly. I think there's a difference in how initialization and memory allocation works for them and how that you can compare to structs and all that.
Okay.
I think Rust might not have classes.
All right.
As a concept.
Gotcha. Okay, so we're going to have this public struct, and where should we put this?
I'm going to put it here.
Okay.
It doesn't specify. I'm going to assume that it's not relevant.
Okay. So did you just choose your favorite line 18, or just that was where your cursor was, or it makes some kind of intuitive sense to you?
Whenever I'm declaring structs or that sort of thing, I tend for the top.
Okay. Yeah. Makes sense. Okay, and so what is that? What's that A? We've got like a little in our pointy brackets. We've got the apostrophe A. Who's that?
I have no idea. Let's find out.
Oh.
Okay. So usually these bigger than and smaller than signs denote what's called a generic, which means that we can declare a timer to use any type. But then apostrophe A comes in and I have no idea.
Okay.
So timer Rust apostrophe. I've encountered a number of types in Rust denoted with a single apostrophe. What is the significance of the apostrophe? Maybe it's a modifier of references, generic typing. I have no idea where the documentation for this is hiding. These are Rust's named lifetimes.
Oh.
Every reference in Rust has a lifetime, which is the scope for which that reference is valid. Most of the time, lifetimes are implicit and inferred, just like most of the time types are inferred. Similar to when we have to annotate types because multiple types are possible, there are cases where the lifetimes of the references could be related in a few different ways. So Rust needs us to annotate the relationships using the generic lifetime parameters so that it can make sure that the actual references used at runtime will definitely be valid. I have no idea what I just read. This isn't a knock on the documentation. Lifetime annotations don't change how long any of the references involved lived. In the same way that functions can accept any type when the signature specifies a generic type parameter, functions can accept references with any lifetime when the signature specifies a generic lifetime parameter. What lifetime annotations do is relate the lifetimes of multiple references to each other. Akio says, same. Yep. No idea what we're reading here.
Yeah, I still have. I'm like, oh, okay, cool.
I'm still going to read it out loud because I'm seeing a very
Sure.
helpful said another way
Mhm.
lower down. I'm very excited for that. Lifetime annotations have a slightly unusual syntax. The names of lifetime parameters must start with an apostrophe. The names of lifetime parameters are usually all lowercase, and like generic types, their names are usually very short. Apostrophe A is a name most people use as a default. Lifetime parameters annotation go after the ampersand. We see that here of a reference, and the space separates the lifetime annotation from the reference's type. Said another way, a lifetime approximation approximates the span of execution during which the data a reference points to is valid. The Rust compiler will conservatively infer the shortest lifetime possible to be safe. So what it's doing in this context is grabbing a parameter and storing it for as little time as possible. If you want to tell the compiler that a reference lives longer than the shortest lifetime, you can name it, saying that the output reference, for example, has the same lifetime as a given input reference. So I think what that means is that we're telling Rust, hey, we have control over how long we'll have access to this name string. Does that make sense?
Okay. And A is like foo or bar in this context. People just use it by tradition.
Yes.
But it doesn't mean anything in itself.
Just like generics, I don't know if you've seen other generics with like T and U. Usually a lot of generics use a capital T or a capital U to denote this can be any type. Okay. And I think it's convention.
Gotcha. Like using X and Y in math. Okay. Fair enough.
Oh, that messes with my head. But you're absolutely right. No, X and Y in math being just like names we accept. But you're right, they're names we accept.
Oh, yeah.
I don't know why that bothered me. In a good way. In a good way.
Okay, right. Cool. So that's what's going on there. And then we've got our implementation of timer. And that's going to have a public function called new. And that, right. So we would call that with like timer.new or something like that. Because we also have a universe.new, right? Like we've got a lot of functions called new going on here.
This is to initialize a timer.
Yep. Okay. And so then we're going to have a console colon type. What does colon mean in Rust again?
Access inside a module. Go into a module and use this. So we're going into console and accessing time with label.
Okay. And I don't know, did we declare that already? Time with label, like what that is?
No, that's what we imported from here.
Oh, okay. That's part of WebSys console?
In fact, we should have access to. Yeah, here. You can use these functions directly via the WebSys crate.
Okay. Nice. And so then we are giving our timer a name, right?
Yes. So when we make a new timer, we give it a name.
And then we're going to implement a drop for timer. Okay, so we're going to have like timer starts and then timer stops. And so then we're going to call our console our time end with label idea or function.
Yeah.
So that we can finish it.
I suspect at a glance that drop will be called automatically once the memory for that timer is deallocated. That means that when we declare a timer, we just declare it, it does its thing. And then when the function where that timer, or the scope rather, where that timer was called ends, and the Rust compiler, the Rust garbage collector goes to drop that value. This is kind of like a callback that says like, hold on, before you drop me, let me end the timer.
Okay.
Which I didn't know was a thing. So this is bringing back some big Objective-C memories for me.
Okay, great. And so then we're going to time how long each tick of our universe takes by adding this snippet to the top of the method. And that'll be the tick method, right?
There it is.
And so we're going to add this let timer equals timer : new universe : tick. All right. So every time we run our tick function, we'll have a timer. Our timer will start, right?
Yes.
Yeah.
Shall we talk about why we have it with an underscore, or have we covered that already?
Ooh, yes. I actually hadn't spotted it.
I was hoping you would.
Sorry.
No. This is I'm gonna hide our faces so you can see. So this is nothing more than a note to the compiler saying, "Hey, we're not going to use this variable." I'll show you what I mean. Let's remove the underscore and try compiling.
Yeah. Right. I've experienced that before, where a compiler was like, "Hey, you didn't use this thing."
You can see it here.
Yeah. So, but we aren't going to use it?
We're not going to call it.
Oh.
We're just going to declare it. It's weird, right?
Why?
Because it does stuff on its own without us being involved with it.
But somebody has to call it for it to do stuff, right?
Yes. And you're right. Let me just restore that. You'll see the warning is gone. But here's the thing. Let's look at our timer struct again. This is a function for initializing it. It does some stuff. This is the function that automatically gets called when it's deallocated.
Yeah.
So we don't actually need to interact with it. We just need to sort of like drop it in and just be like, all right, do your thing.
But what's starting the timer?
Here.
If we're not using it. Okay, so maybe I'm misunderstanding. Because I was thinking of this implementation as sort of like a declaration. Like it's not going to do anything unless we call it, but it will.
Well, this is the function new. When we do, and function new returns a timer.
Yeah.
We can call this function something else. Make a new one.
Yeah.
Just that it's called new. So when we go here, we're going into the timer struct, and we're calling the function new, which starts up a timer.
But we're not, because of the underscore in front of timer?
No, right. We are storing this initialized struct into this variable.
Oh, okay. Gotcha. Okay, but we're not going to use the variable.
We're not going to exactly. It's not that we're not going to use the timer. It's that we're not going to use the variable.
So that's really interesting. So you can't call the timer without assigning it as the value of a variable.
I don't agree. This is what annoys me. I think we could do this. We could just
Okay, because that would make so
initialize
much more
one.
sense to me.
But let's see if it compiles. Maybe you and I agree, but Rust doesn't.
Okay.
Oh, it does.
Oh,
and we got a question from Akil. Is underscore a Wasm thing or Rust? Because we also use underscore build in mscripton building project. I have to admit I've never used mscripton. Are you familiar with mscripton, Laura?
I know that we're going to talk about it in episode 2 of Explain Like I'm 5 WebAssembly.
Yeah.
And I will know more about it after episode 2.
Nice.
That's what I got for Inscription so far.
Yeah, and I think in this context, specifically, we're talking about Rust. So the Rust compiler wants us to have that underscore.
Probably Akil knows a lot more than we do about Inscription.
Yeah, I'd love to hear more about this underscore build thing.
Definitely.
But maybe he wants to join us sometime on stream.
Yeah.
You'd be more than welcome, Akil. Like,
absolutely.
Send us a DM. Like, I think you can find our Twitter in the description of the YouTube video. Send us a DM.
Yep.
You'd be more than welcome. Where were we? Yeah, so we're starting up a timer. Sorry, yes.
Yeah. So we're starting up a timer, and we are coloring outside the lines here because we're not using it as the value of a variable that doesn't get used. We're just saying, just use the timer. Because that makes sense to us. And maybe we're going to find out later that something else doesn't work, but this is how we're going to do it for now because we're rebels, right?
Yes.
Okay.
Akil says, seriously, but yeah, no,
yes.
DM us, please.
Yes, 100% seriously.
Yeah, why not?
Yep.
We're all having fun here. Okay.
Sure.
So the timing should now show up here. Let's have a look. I remember how to open the dev tools in Chrome. Okay. Now it would appear to me that it's not. We should remove this. Do you mind if I do?
Yeah, not at all.
Remove that and start over. Wasm pack build.
Which changes require us to rebuild Wasm pack versus just refreshing?
Changes to the Rust code, the WebAssembly code, needs to be repacked.
Okay. Gotcha.
Does that make sense?
Okay.
By the way, Laura, check it out.
Yeah, we've got timing.
So I don't want to brag, but a universe take on my computer is taking about 0.0017 milliseconds, whereas on the tutorial it's taking about a millisecond. So I think computers have gotten better since the tutorial was written. To be fair, this is M1, so like maybe it's a bit faster with that.
Yep. Could be.
Additionally, console time and console end time and pairs. Oh, sorry, I'm navigating again.
No worries.
It's a really bad habit of mine.
They'll show up in your browser's profiler's timeline or waterfall view. What is a profiler of a browser? I don't think I've seen that before.
Let's have a look. Now, this assumes that we're using Firefox, so it's going to look a little different in Chrome.
Sure.
So I don't actually know. Is it application? No. Elements. Performance.
Okay. Okay. So this sort of ties back into the title where we referred to it as time profiling rather than performance,
Yeah.
but they're used sort of the same.
Well, you time profile your application to measure the performance of your app.
Mm-hmm. Right.
And Akil's asking, so you're using Wasm Pack to convert Rust in WebAssembly? Exactly. Exactly. We're using that. So we're building a node package and then integrating that into our front end.
Mm-hmm. Yep. The magic of WebAssembly.
Magic
Write
of
in Rust
WebAssembly.
and deploy in JavaScript.
Yeah. So here we go. Now the question is, what good is this?
Right.
Additionally, the console time and console timeout. So there's a waterfall recording. You can see the universe. Okay. Now, unfortunately, it looks a little bit different in Chrome, so I don't actually know how to navigate this console. Oh, look, there you can see. Oh, look at that. That is fancy.
So that's interesting. So I don't think I've seen. So that says mu s.
Yeah.
Like 5 mu s. And is that
Nano.
milliseconds?
Isn't that nano?
Nano. Okay. I haven't seen that unit before. Muse.
I think nanoseconds. Let me see. A nanosecond. NS. Okay, maybe I'm wrong. Mu second. Micro, sorry.
Ah, okay.
Microseconds.
Right. Okay.
Nano would be pretty impressive, I think.
So we're using mu because we've already used m as milli.
Yeah.
And so mu, yeah, okay, right. And Akil is way ahead of us.
Yep. Thank you.
Akil should be teaching us this tutorial today.
Absolutely. So, yeah. So that's how that works.
Cool. All right. And so now we can grow our Game of Life universe. How are you for time?
We've got some pairing to do.
Mm-hmm.
We can, let's see, we're about, I think this is going to require multiple parts.
Yeah, I think so.
So I think we're at a good stopping point, actually.
Mm-hmm.
MDS says, just like uTorrent is actually microtorrent. I didn't
know that.
Yeah. So it was always the mu. I always called it mu torrent.
Mm-hmm. Nice.
Yeah. Cool. Yeah, I think we're at a good stopping point today.
Yeah.
Covered a lot, and we can carry on the next time. Hey, thank you both for joining.
Yes, thank you so much.
Yeah, always good to have you. Yeah, and Laura, thank you so much.
You being Akil and Midia and anybody else who has joined us, not specifically. We're not thanking ourselves at this point. We're thanking you.
Well, I'm thanking you,
just
Laura.
To be clear.
You were very helpful.
Yes, and thank you, Ramón.
Absolutely.
This is super fun.
It's been a joy. Take care, everybody. Have a good one.
All right. You too.
Bye.